Basics of Statistics, Part 6.
In previous lectures, we explored how linking two or more variables can be approached statistically in four main ways: estimation, correlation, comparison, and regression. We also reviewed the primary statistical test for comparing two groups or more, as outlined in this table. The results of these tests give us a p-value, which we can use to decide whether to accept or reject the null hypothesis. Another statistical approach is estimation. In this lecture, we'll cover concepts like relative risk and odds ratio. Suppose we want to determine whether a mutation in the RK gene is linked to breast cancer. One approach is to conduct a cohort study by following a group of healthy women at risk of developing breast cancer over a specified period. During this time, we would track how many of them develop breast cancer, while also using a single gene test to monitor for mutations in the RK gene. Suppose we followed 1,000 women for 10 years, and 120 of them developed breast cancer. Of these, 75 women also had the mutation. Meanwhile, among the healthy individuals, 140 showed the mutation without developing cancer. Now let's explore how to estimate the risk of cancer associated with the presence of the mutation. We can organize these values into a 2x2 table. This allows us to calculate the remaining values. For instance, among the women with breast cancer, 45 did not have the mutation. It's important to note that breast cancer is our dependent variable, while the mutation serves as the independent variable. Now, by calculating the probability of developing cancer among those with a mutated gene and those without it, and then dividing these probabilities, we can determine the relative risk value. In this example, the relative risk is calculated to be 6.1, meaning that individuals with a mutated gene have a 6.1 times higher risk of developing breast cancer compared to those without the mutation. It is important to note that the relative risk is calculated in direction of the independent variable. Additionally, since these findings come from a cohort study, with 120 out of 1,000 women developing cancer over 10 years, we can calculate the annual incidence of cancer by dividing 120 by 1,000, and then by 10. This gives an incidence rate of 0.012, or 1.2% per year. Relative risk equal to 1 means no risk, or the exposure doesn't affect the outcome risk. Relative risk less than 1 shows a protective effect, or the exposure reduced the risk. If we calculate a relative risk of 0.8, it means the risk is reduced by 0.2, or 20% lower after exposure. Values more than 1 means the exposure raises the risk. If the relative risk falls between 1 and 2, we report it as a percentage. For example, a relative risk of 1.4 indicates a 0.4 or 40% increase in risk after exposure. Any value over 2 should be reported as is. For example, a relative risk of 2.6 means the risk is increased 2.6 times after exposure. Another possible approach to determine whether a mutation in the RK gene is associated with breast cancer is to conduct a case control study. Suppose we include 100 women with breast cancer and determine whether they have a mutation in the RK gene. We then match and pair them with 100 women who do not have cancer and check for the mutation in these individuals as well. Then we can make a 2x2 table and include the remaining values accordingly. This time, in direction of the independent variable, we calculate the odds of developing cancer in the group with the mutation and in the group without the mutation. By dividing the odds, we obtain the odds ratio, which in this case is 4.5. This indicates that having the mutated gene increases the odds of developing breast cancer by 4.5 times. As you see, odds ratio is also a way of estimating the risk associated with exposure. We can interpret the odds ratio in the same way we interpret the relative risk.
Thank you for watching.